Okay, this is U4L6, and we're talking about multiplying and dividing complex numbers. So let's look at a little bit of review on complex numbers. Remember that I is radical of -1. So real quick, if you have radical of -2, that's, radical of -1 times radical 2. So you take out the negative part, right? It's always going to take out the -1. So to turn that into a positive radical, then I have I radical 2, okay? If you have radical of -24, you take out the -1 radical there. So, and then you simplify the radical 24. Then you have 2i radical 6, because the 24 gives you a 2 that goes outside. And then you have radical 6. So you write the number in front of the I and then the radical. Okay, that's the order that you should write them. Same thing with radical -25. I take out radical -1 and then radical 25. And radical 25 gives you 5. So I have 5i. Again, the number goes in front of I. And if you have a radical, then it goes behind the I. Now let's talk about multiplication of I. If I is radical -1, I squared's got to be radical -1 squared, which gives you just -1. Okay, so from here on out, really try to keep in mind I squared is -1. That's really important. Let's talk about multiplying radicals here, or multiplying complex numbers. Remember, I squared is -1. Keep that in mind. Okay, so if I have this multiplication here, 5i times the quantity of 8 minus 9i. Remember, 8 minus 9i is a complex number, right? It has a real part and an imaginary part. So I multiply this. I just distribute like I normally would. 5i times 8, right? Is 40. And then 5i times -9i is -45i squared. Okay, 5 times 9 is -45. I times I is I squared. Now I squared, remember I squared is -1. So I have -1 there, like that. And so that's actually -45 times -1. It changes the sign of this 45. So I get positive 45 plus 40i. And I move the number in front. Real part goes in front. Imaginary part goes in the back. Here I have two complex numbers multiplied to each other. So you can FOIL these. You do each part, real part, imaginary part, separately and FOIL them. So I get -10, all right, plus 4i minus 5i plus 2i squared. Okay, just like pretend I is like an x and you FOIL. It works the same way. Okay, now the middle terms can combine, and I squared is -1. So the middle term gives me 4i minus 5i gives you -i plus 2 times -1. Now, see, the I squared is just going to change the sign of my positive 2 becomes -2. So I have -10 minus 2 gives me -12 minus I. If you have three numbers multiplied together like this, three complex numbers. So I'm going to distribute this 2i in here first. So I get -16i plus 4i squared. And then the 4 minus 7i is still in the back here. See, but I squared here, I don't keep going. Do not keep going and multiply this out before you change this. You see I squared, immediately change this to a -4. Okay, the I squared changes the sign of your number, so it becomes -4, and I squared goes away because I squared is -1. So my 4 becomes -4, and it goes in front. Imaginary part goes in the back. So -4 minus 16i, and here I FOIL this out again, and I get this, right? I FOIL this out, -16 plus 28i minus 64i plus 112i squared. The I terms here combine, right? And this is -112 because of I squared makes this becomes a negative. So together now, I didn't do that yet. So I put a -1 in for I squared. So typically you want to skip that step. Like if you're good at it, you can just say, oh, that's -12, 112, and I add it to the front. But here I wrote it out so you can see I squared is -1. And then you combine that. Oh, I wrote out some more steps. So that becomes -112. And then you can combine them. You have -128 minus 36i. So again, these little steps here, you could possibly skip them if you know I squared is -1. And it changes the sign of your number. Okay, let's go on to divide divide complex numbers. The whole idea is that you can't divide it. You can't really divide it. So what you do is you can't have I in the denominator. So what you really do is rationalize it. Okay. The problem that we have is that we cannot have I in the denominator. So we have to get rid of it. So you see this here, I have a complex number divided by this complex number here. And typically you can't do anything, but you want to get rid of the I at the bottom. So what you do is just like radicals, right? You have multiply by the radical of the same thing to get rid of the radical at the bottom. Here, you don't need to multiply by 12i. You just need to multiply by I. Okay? If you have just an imaginary number here, multiply by I. So what happens is I have I times this whole thing and I times this at the bottom. So I haven't done anything. I just put it together so you guys can see it. Now I'm going to distribute the I in here. Distribute. And I get 4i plus 9i squared. At the bottom, I have 12i squared. You see, I squared here, it goes away. I squared becomes what? -1, right? So I have -12 at the bottom. And I squared here makes this 9 becomes a -9. And it goes in front. -9 plus 4i. And then I'm going to split this up. You could do this. For me, I don't really care if you do this or not. But typically, you want to split this into a real part, imaginary part. So you split this into two different fractions. Real part, -9 over -12, and then 4i over -12. And then you simplify that. I get 3/4 minus I over 3. So I cancel the 4 with the 12. And the negative here makes this a negative. Right? This is a little bit different. You see how I have 3 minus 2i at the bottom? It's different from here. This one has only 12i. There's no real part in front. So there's no real part. I multiply by I. If there's a real part and an imaginary part, you have to multiply by the conjugate. Because if you multiply by I, the I goes and multiply by 3i. It stays. It doesn't disappear. All right. Here it disappears because I times I disappears. So here I have to multiply by the conjugate of 3 minus 2i. Just like with radicals, it's the same thing front and back, but it changes the sign. So I have 3 plus 2i as the conjugate. So multiply that by top and bottom. So here I have 6i times, my 3 plus 2i. And bottom here I have 3 minus 2i times 3 plus 2i. Remember, when conjugates multiply by each other, you have the square of the first minus the square of the second. So what I have is the square of the first is 9. The square of the second is 4i squared. And just the first minus square of the first minus square of the second. I get 9 minus 4i squared. And the top I distribute like how I normally would. And here, every time you see I squared, you change that to a negative, or you change the sign of the number. So I have 4 plus 9. I mean 9 plus 4 now. See, 9 minus -4. And here I have -12 plus 18i here. See? So I have 13 at the bottom. And you can split this into a real part, imaginary part. So -12 over 13 plus 18i over 13. Same thing here. I'm going to do it again. I'm going to do by the conjugate. So I multiply by 5 plus I. All right. And the top I have to FOIL. And the bottom, it's just the square of the first minus the square of the second. So I have 25 minus I squared at the bottom. See? In the top you FOIL. You get this. And remember, when you FOIL two complex numbers, the middle terms can combine, and the last term gets I squared. So you change the sign of that. So 15 minus 4. See, 15 and -4. The middle terms combined becomes 23i. And the bottom here, I squared, is -1. So 25 minus -1. And combine that, I get 11 plus 23i over 26. And split that, and I get 11 over 26 plus 23i over 26. The last thing we have to do is plot complex numbers. And we plot that on the complex plane. The complex plane is this. It looks just like a regular coordinate plane, the Cartesian plane, but the x-axis is now called the real axis, and the y-axis is the imaginary axis. Okay, so the way it works is, see, you have a complex number. You have a real part and imaginary part. Real part is the 5. Imaginary part is the 3 here. So when I plot this, I take 5 and I go on the real axis. +5, I go 5 to the right. And +3 on the imaginary axis, I go up 3. So A is right there. Okay. Again, the real part is left, right. Imaginary part is up, down. Let's do B. 2 minus I. So real number is 2. So 2 to the right. Minus I, that means I go down 1. So my B is right here. C, negative 2 plus 4i. So the real part is negative 2. I go left 2. And then the imaginary part is 4. So I go up 4. C is right here. And then D is just negative 5. There's no imaginary part. So I go to the left 5 and I stay there. No up, no down, because there's no imaginary part. And E is negative 5i. That means there's no real part. I don't go left. I don't go right. I just go straight down to negative 5. That's E.